All right. Welcome, welcome. Welcome to our free LSAT prep hour. And yeah, I just realized I have the wrong date up here. It's not June 24th. It's December, what is it? December 15th, December 15th, 2020. Sorry, 2019. I've been saying 2020 and wanting to write 2020 for like 3 weeks now. I guess I'm in a hurry for it to be 2020 or something. So yeah, ignore that goofy date there. It is not June 24th. It is December 15th, 2019, and this is our free prep hour for tonight. My name's Scott Miller. We're off to a great start. It's going to be a fun session. My name's Scott Miller. I'm going to be your instructor tonight. I'm based in Durham, North Carolina, and I teach LSAT courses, do private tutoring for Manhattan Prep, and I do these free prep hours. And so we do these free prep hours twice a month for the benefit of anybody who wants to join us live, or like I said, we put them up on our YouTube channel. We record them and put them up on our YouTube channel. And this is just basically a way for people to get a little bit of good information about the LSAT. Some other ways you can get good information about the LSAT is we have some good free resources on our website. And I will, at the end of the session, I'm going to put up some links in the chat window. And so links to the free resources on our website. So you don't have to worry about writing any of this down or anything. But one thing, and if you're watching the recording, in the information for the video, you'll find the same links to the free resources on our website. One of the great ways, though, if you want more information about the LSAT, if you're trying to prepare for the LSAT, you know, and you come into these free prep hours, another really great way to get some prep is to attend one of our free trial classes. So basically, any of our LSAT courses, in person or online, for any of those, we offer people the opportunity to attend the first session, just session one, the very first session, for free. And you know, I recommend you take advantage of that. Just go to our website, sign up. Like I said, I'll put the link in the chat window or at the end of the session, or you can find it in the information for the video, and just, you know, show up for session one. It's a 3-hour, not just a 1-hour free prep hour, but it's a 3-hour class on the LSAT. And we share a lot of good information right in that very first session in session one. So if you have any interest, go ahead and check that out. Go to our website, look at the upcoming schedule of courses, and sign up for a free session one. So there's a good question in the chat window about how much time do you need to be ready. So I'm just going to answer that right now, since somebody put that in the chat window. And again, I'm going to recommend that you do put questions in the Q&A. I'll try to get to as many questions as I can, but just for that first question, since that's one that a lot of people have, how much time do you need to be ready? So what it depends on is really 3 things. How much time you need to prepare for the LSAT depends on what your goal score is. What score do you want to get or need to get to attend the law school, or to be admitted to the law school that you want to attend? What are you currently scoring in practice tests? So one of the first things that I always recommend, if you have not done so, if you're preparing for the LSAT or thinking about preparing for the LSAT and you haven't done so, take a full-timed, realistic practice test. You can go to the free resources page on our website. The practice test can be a paper test. You don't have to do the digital format for your first practice test. It's just a diagnostic test and gives you an idea, just a good general idea of how you would score on the real LSAT if you went and took it tomorrow. And so based on what your score is on that diagnostic test and what you want to score to get into the law school that you want to attend, and then how much time do you have every week to spend preparing. Those 3 things will pretty much tell you how long it's going to take you to prepare. To give you an idea, you know, if you're within just 2 or 3 points, or maybe 5 points or less of your goal score, maybe a month might be enough. If you're any more than that, if you're looking at increasing your score by 10, 15, or 20 points to get into your goal law school, it's possible. It's very possible to do that. I do see students do that quite often, but it takes time. It's not going to be a 1-month deal. If you're looking to increase your score by 10 points, 15 points, 20 points, you're looking at several months of prep. You know, it's not unusual for somebody to prepare for the LSAT for 6 months or more if they're looking for, you know, a really top score up in the 170s, or especially if they're looking for a fairly big increase. So that was a great question. I just thought that would be a good way to start off, since a lot of people have that as a general question, especially if people are fairly new to the LSAT. But again, any other questions that you have, especially if they're not directly related about what we're talking to tonight, this topic coming up that we're going to talk about tonight, put those in the Q&A window. Use the Q&A window and I'll answer questions that way. So here's what we're covering tonight. We're going to talk about hypotheticals. We're going to talk about logic games, the logic game section of the LSAT, and how to create hypotheticals and what hypotheticals are. We're going to use a game from our Logic Games Challenge page on our website. So if you attend one of our courses, or if you get our Manhattan Prep strategy guides, or you use our Manhattan Prep LSAT Interact course or lessons, we use actual LSAT questions from previous tests in those resources, in our courses, in our books, in our live, our interactive Interact lessons. But for this session tonight, I thought it'd be fun to use this one game from our Logic Games Challenge page, because it illustrates a couple really interesting points about what hypotheticals are and how we use them. So I'm kind of breaking tradition here a little bit and using one of the games that we made up for this session tonight. One thing I want to mention too right now is we do, when you sign up for this free prep hour, if you've signed up to join us live tonight, you may have received a link to a survey. And I know people will click on that link, and in the survey you can ask a question. And we do look at those, and we use the questions to prepare for these sessions. So I did look at the questions that people submitted before this session. I may not be able to answer every single question that people submitted, especially sometimes people submit really, really specific questions about, very specific LSAT questions on specific tests. And, a lot of what we do in these free prep hours depends on looking at the big picture of all the questions that people have asked. So I will give you some suggestions at the end, if you stick around till the end, for what you can do if you have a really specific question, or just any question that you asked in that survey, if you signed up to join us tonight. To be with us here live tonight. If you asked a question through that survey and I don't answer it tonight, I'll give you some suggestions at the end of how to get some more information. So let's dive into this topic. Let's dive into what we're talking about tonight. And actually, if I can, in the chat window, I'm really interested in two things from everyone. If you would, just quickly in the chat window. Yes or no, have you taken the LSAT already? An actual real LSAT? And the other question is, how long have you been preparing for the LSAT? So that can be anything from 0. Right now, I just came here tonight to find out what the LSAT is about. So give me anything from a 0 to a number. Okay, I was seeing 2 weeks, weeks, months. How long have you been preparing? Okay, so we got a lot of people who are really new to the test. That's great. It's usually kind of a mix. Okay, and we have some people who are a little bit more familiar with it, preparing for a little bit longer, 8 months. Okay, so that's not unusual. You usually have quite a few people who are pretty new to the test in these free prep hours, and we have people who are have been preparing for a while. So hopefully what we'll give you tonight is a little bit of useful information for all. So let's start by playing a logic game. If you've been preparing for the LSAT for a while, and you've taken the LSAT already, you know what to do. When I show you this next screen, we're going to show you the setup for a logic game, the scenario and constraints. If you're totally new to the LSAT and you never have dealt with logic games before, then what I'd like you to do is just draw a little sketch or diagram based on what you see on the next screen. Try to draw a little sketch or diagram or a few notes to represent, in your own words, to represent what you see, this situation that you see on the screen. I'll give everybody, I don't know, just maybe 2 minutes to do that. Minute and a half, 2 minutes. So go ahead and take some notes here, or do your diagram if you're familiar with logic games. All right, so that was about a minute and a half or so. So let's talk about this. Every time when you're working on the logic game section in the LSAT, they're going to give you 4 games, and at the beginning of each game, they're going to tell you a little story. We call this first part the scenario, and the bottom part the constraints or rules. So the first thing we want to do when we read the scenario and the constraints, I always recommend you read all the way through them. I don't know if everybody does this, but I always recommend that the first thing you do is read all the way through the scenario and the constraints, just to kind of get the big picture of what's going on here. And then we're going to start a diagram. We're going to do a little sketch, a little drawing to represent this scenario and these rules so that we don't have to go back and read this every time. So this is what we call an ordering game. Everything, all this information here, all this information they're giving you are about putting these friends in order and figuring out what the order is in which these friends graduated. You notice all the rules they give us are about ordering. So the standard way that we deal with an ordering game is first we write out all our elements, so we don't have to keep searching for them inside this little paragraph. We write out all our elements, then we draw a number line, 1, 2, 3, 4, 5, 6, 7. These are the 7 years in which the friends graduated. We're trying to figure out the order in which they graduated within those 7 years. So we have this first rule here. K graduated 2 years before O. Can somebody in the chat window, or everyone in the chat window, show me how, can you maybe show me in the chat window how you diagrammed or what kind of note you took for this first rule? K graduated 2 years before O. What would that look like on your diagram? Okay. Cool. Awesome. All right, so I'm seeing a few different things. I'm seeing K and some dots and O, K space O. So there are a few different possible ways to do it. One of the things you might see is just K and O right next to one another. So, or we see K and a space and O, or K and 2 spaces and O. So what is it? How do we, and this is not unusual to see a rule like this in a logic game. You want to be really clear on what this rule is actually telling you. So let's say O graduated in year 4. If O graduated in year 4, what year did K graduate in? Yeah, I'm seeing it in the chat window, 2, right? That would be 2 years before. 3 would be 1 year before. 2 would be 2 years before. So this is our correct way of diagramming this. K and then a space, or I don't just leave a blank space. I do like an underscore and then an O. That is diagramming our first rule. And this is one of the things in logic games you're going to have to get used to, is correctly interpreting the rules. And especially rules like this, 2 years before, there are exactly 2 between. Make sure when there are spaces in between rules that you're really clear on what the rule is saying and exactly how many there are. Even, if you need to for a second, draw a little sketch on the side. So, okay, if O is here, and then 1 year, and then 2 years, and then figure out where K is. It's important to get rules like this correct, even if you need to take just an extra second to figure it out. Okay, P and M graduated in consecutive years, although not necessarily in that order. And I'm going to show you a really common way that people diagram a rule like this, not because they don't understand it, but because people get a little lazy, and they'll do something like this, P and M together next to one another. P and M graduated in consecutive years. What's wrong with that? The thing that's wrong with that is that P doesn't have to be first. It says not necessarily in that order. And if I look at this a few minutes later, then I might get confused and think that P has to be first. So the correct way to diagram this is, make sure the or is clear, the either or. This is what we call a reversible chunk. P and M have to be right next to one another. We put a box around chunks when they give us like a definite connection, a definite distance between 2 elements. When it's a fixed distance between 2 elements, we put a box around them. We call that a chunk. Make sure you recognize that this is reversible. It could be P first and then M, or M first and then P, but they have to be right next to one another. And these last 2 rules, pretty straightforward. N graduated 3rd. We can drop N right in 3. L did not graduate 6th. Usually if we're going to exclude something, if we're going to say something didn't happen in a certain position, we cross it off underneath that space. So this would be our initial diagram for the logic games. And this is the first thing we're going to do when we're working with a logic game. We're going to read all the way through the scenario and the constraints. We're going to picture the game, and we're going to draw a diagram to just represent what's going on in the game and the rules. And again, one of the purposes of the diagram is just so it should clearly represent the rules, so you don't have to read this over and over again. You can just quickly look at your pictures, your sketch, and understand what the rules are and the relationships between these elements that they're giving you. Okay, so the next step, the next thing that people often want to do at this case, and Mustafa, I saw you did this in the chat window, right? You're thinking about hypotheticals already. So a hypothetical is one possible valid solution to a logic game. And it looks like Mustafa gave us, a couple possible solutions to this game. So here's what people will often do. One of two things that people often do at this point is they start thinking about where things can go, right? Like you might notice like, oh yeah, M and P, they could be like first and second. I could have M and P first and second, or I could have P and M first and second, and then it would be N. And you start thinking about possibilities and what could be. Or the other thing that people do very often is they'll start creating complete solutions, right? People will start drawing these out like, oh, okay, so I could have P, M, N, and then I guess I could have K, and then a space, and O. And you start drawing out these different possibilities, these different possible solutions. It's very common for people to do one of these two things, either just kind of think about a few specific could-bes, or even go to the extreme end of drawing complete solutions. And people will sit here and try to create sometimes as many complete solutions as possible. How many people have ever done something like this when you were playing a logic game, when you were working on a logic game, just kind of sat here and tried to draw out a bunch of complete solutions? Some people said they've been preparing for a while. Have you all ever done this? I see people do this a lot, right? Yeah, okay, I'm getting some yeses. So here's the thing. Only initially, yeah, Catherine figured it out, right? This is a trap. At this point in the game, once you do your initial diagram, people always want to, yeah, Catherine, it's too slow, right? Catherine said in the chat window, it's too slow. People always want to try to figure out as many different could-be possibilities as they can. And if you're trying to draw out complete solutions, first of all, some games have like 20 possible solutions. There will never be just one or two, possible solutions to a game. There will be many. Maybe there could be a limited number, like it might be 6 or 8, but that's still a lot to try to write out every single one. And usually it's more than that. I mean, there can be, like I said, 20 or more solutions to any given game. So people want to do this all the time, but it definitely is it's a trap, right? It's a way that just eats up the clock. So what you really want to do, two things you want to be comfortable with. First of all, when you go to answer the questions in a game, you want to be comfortable with just a general diagram like this that represents the rules, that represents the game. And you want to be comfortable with the fact that you're maybe not going to know any possible solutions at this point. You might not figure out any possible solutions until you go and look at questions. So this is, I say, if you notice, I mentioned earlier, in the little title screen we had earlier, I mentioned that I'm going to talk about when to use hypotheticals and when not to. So this would be one time that you would not want to use hypotheticals. You wouldn't at this point want to try to figure out as many could-bes as possible. What we want to focus on at this point is what must be. So when we're talking about logic games and we talk about things that must be true in a logic game, now we're talking about inferences. This is what inferences in a logic game are all about. One definition we can use for an inference is, recognizing things that must be true, things especially that were not given to you in the rules, that were not explicitly stated, but that must be true. So somebody tell me something that must be true in this game, like a definite, something that is maybe might be a little bit misleading. So let's say something that's definite in this game, something we definitely know about any of the spaces. Does L have to be last? Does L always have to be last? What I usually do at this point is I'll create a hypothetical to show you that L could be somewhere else. But this isn't something we would normally do, is try to figure out as many things as possible. But if you do make an inference, if you want to know whether or not, like later on when you're going back and reviewing a game, and if you made that inference and you said, oh, I think L has to be last, and then after you've played the game and answer all the questions, you start questioning that. You go, well, wow, does L have to be last? Is that a mistake, or does L really have to be last? Was I right or wrong? What you can do is just try it out. 1, 2, 3, 4, 5, 6. 7? Yeah, so let me like stick N here and K here and O here. L can't be 6, but what if I put L here, M and P here, and R here? Right? That's a hypothetical. I just created one possible solution to answer, DeMarcus, what you suggested. Does L have to be last? So now we know that it doesn't. I'm going to show you one thing that is an inference in this game, though. Something that must be true. O cannot be first. That is something that must be true. That is a definite in this game. Can anybody explain to me in the chat window, why is it that O cannot be first? Yeah, because K comes before. Not just K, but K and one other element come before O. So in fact, where else can K not go? Yeah, K comes before O. There's another place where O cannot go. If I have to have K and a space and then O, what other space can O not go in? Yeah, O cannot be in 2. So in order for hat to have room for this whole thing, I can't have O in 1 or 2. Does anybody notice where K cannot go? So, we made some exclusions over here. We know elements cannot go in certain spaces based on this chunk. What about K? What is K? How does K limit us? Yeah, K can't be in 6 or 7 because, again, if K is in 7, I don't have room for that space in O. In fact, if K is in 6, I only have room for K in the space, but I still don't have room for O. So chunks very often in ordering games are going to prevent elements from going in certain spaces. And it's good to note that on your board, right? Okay. I'm wondering if anybody notices there's actually something else we know about this KO chunk, and it actually limits K and O in another way. There's actually somewhere else that K cannot go and somewhere else that O cannot go. Does anybody see it? Put it in the chat window if you see it. I can cross K off under another one of these spaces. I can cross O off under another one of these spaces. What happens if K is first? Where does O go? Yeah, O would have to go in 3. O's sitting on N's lap, and this ain't that kind of party. So we can't have K in first. Yep. So again, another inference. So anytime you have any kind of a chunk, any kind of thing like this that puts 2 elements in a definite position next to one another and in a definite order like that, definite position or definite order, we would notice, you want to make sure, this is always going to tell us that a certain element can't go in a certain space. The earlier element isn't going to be able to go too far at the end. The later element isn't going to be able to go too far in the beginning. And then when you have like a blocker, a speed bump like N already knows where N, we know where N's going. We know where that N is in 3. That also may prevent elements in a chunk from going into certain spaces. So where is O blocked from going based on N being 3rd? Where is O prevented from being based on N being 3rd? Yeah, 5. You got it. O cannot be 5 because, again, that would put K in 3 and N is already occupying space 3. So these are inferences. These are, I call them exclusions, right? Elements excluded from certain spaces. The rules prevent elements from being in certain spaces. Reversible chunks generally don't prevent things from going in a specific place at the beginning or end because they can reverse. Like I wouldn't say, oh, M can't be first because it could be. Maybe M is here and P is here. So you have to watch out for reversible chunks. But chunks like the K space O block definitely create some exclusions in a game like this, and you want to be aware of them. And what I always say to people, like if you're first starting out in logic games, this is one of the basic things that you should always do, get used to doing. Once you've created your initial diagram, take a moment to look for these specific types of inferences. Do the rules prevent elements from being in certain spaces? There are some other types of inferences you can make. Like sometimes we can connect 2 rules together in a meaningful way. So that's something to watch out for too. But exclusions, and one thing I say, like even if you're a super advanced logic game wizard, right? You always do really well in the logic game section. If you ever run into a really weird game and you're feeling a little stuck, or you're feeling a little uncertain, or you've created your basic board like this, you've created your basic diagram, and you're not really seeing many inferences, you're not really seeing much going on that you can infer, look for exclusions. This is one of the things that can be really useful in an unusual game or a difficult game if you're, fairly proficient at logic games. Not seeing anything. Like, are there any inferences? I don't know. Because sometimes you get to the point where you're proficient enough and you're comfortable enough that you don't feel the need to write out everything that we just wrote out. You just kind of like, yeah, of course, O can't go first. It has to have K and a space before it. So you just get really comfortable not using the exclusions or writing them out the way we did. If you're at that point where you're that comfortable, I'm going to suggest that in a weird game, an unusual game, if you feel a little lost, a little uncertain, or you feel like you're missing something, start writing out the exclusions, because that can very often show you something very, very important about the game or lead to another inference. So that's a little weird game tip. Some of the things we do that are really, really basic that really good to learn when you first start working on logic games, like these exclusions. They're also good habits to fall back on later on when you're dealing with more advanced situations. So again, at this point in the game, once we've created our initial diagram, we're not going to go down the hypothetical rabbit hole. We're not going to go down this trap of worrying about or thinking about what could be, what are my could be's. We're going to think about what must be or cannot be, and note that on the diagram. That's what making inferences are all about, adding definites to your diagram. All right. And again, if you have questions about any of this, feel free to put your questions in the free to put your questions in the Q&A window if you have questions at all about anything that we're doing here. All right, so the next thing we're going to do in our Manhattan Prep logic games process, the next thing we would do is go through the big pause. So everybody at this point is probably ready to work on some questions, right? All right, we got this diagram, drawing, art class is going great. We have a beautiful diagram. We know what our definites are, our must-be's. Now let's start answering some questions. Before we do that, it's always a good idea to think about, at a minimum, two things. One of the things you want to think about is, are there any elements in this game that are not mentioned in the rules? I call them unruly children. Or, if you want a simpler way of describing them, we can just call them elements without rules. Somebody tell me in the chat window, do we have any elements without rules? And if so, which one of our elements is not mentioned? And again, I know I don't have the written rules up here, but that's okay. You can just look at your diagram and see, is anything missing? Yeah, R. R is an element without rules. It's an unruly child. Some people call them wild cards. So what we want to do is circle R. R is the least restricted thing in this game. So let's put a circle around R on our diagram. The next thing that we're going to do is think about what I call the golden child. You can make up your own fun nicknames for things if you want. Whatever helps you remember to do this. So you can say, like, one way to describe the golden child is the most restricted. What's the most restricted thing in this game? Do you see anything that's really, really, really limited? Yeah, N is very restricted, absolutely. But N is also really, really easy to deal with because it's not going to move at all. Like, all I need to do is remember, like, N, it's right there in front of me, right? I don't have to really think about N. So among the things I have to think about, among the things that can move around, which one of those would you say is the most restricted? It might be a single element. It might be a rule. Yeah, DeMarcus, you said K and O. Catherine, K and O. A lot of people say in the chat window K and O. So the most restricted thing could be a single element that's very restricted. Or it could be something like this chunk. It's very, very restricted. Only a few places where this can go. So it's good to notice both of these things before you attack the questions. Have this fresh in your mind. What's the least restricted thing or things? I mean, there might be more than one element without rules. Some games have more than one. And then what's the most restricted thing, the most limited? That's our big pause. And do this every logic game. And we know you're excited to go and answer questions, but doing the big pause and getting in the habit of doing the big pause can be a very powerful part of your process. And just thinking about those two things, you'll be surprised every once in a while. They are the key, or they make the difference between being able to work through a question really quickly or really struggling with maybe one or two or more questions in a game. All right, so the next thing we're going to talk about, and this is actually part of our big pause. Part of our big pause process is something we call framing. So we create frames. Most games, the majority of games, the majority of logic games that you see, you will attack. You'll go answer the questions with just one single diagram like this, like we have here. Diagram showing the rules and inferences. But in certain cases, we're going to draw some additional diagrams. Some additional diagrams to represent something very specific. So we draw frames when there is a 2- or 3-way split. And considering the split allows us to make additional inferences. This is what framing is all about. So does anybody see what we mean by a 2- or 3-way split is either an element or often a chunk in an ordering game that can only go in one of 2 or 3 different places. Do we have anything like that going on here? Is there anything in this game that's limited to one of 2 or 3 different positions? PM or MP, yep. Actually only, 3 places that can go. So it can go in 1 or 2, well, actually more than that. In 1 or 2, it can go in 4 or 5, it can go in 5 or 6 or 6 or 7. So that's already 1, 2, 3, that's already 4 different possibilities. And then you also realize that M and P can reverse. So there are actually 8 possibilities there if you consider all the different places that that PM chunk can go and the different orders for P and M. That's more than a 2- or 3-way split. It's a good answer, but that's something we would not want to use as the basis for frames because there are more than 2 or 3 possibilities. The most framing I would do, the most possibilities I would consider when I'm framing is 4 maybe. So there is something that can only go in a few different places, and it's the KO chunk. Yeah, Catherine, you're absolutely correct. 1, 2, 3, 4, 5, 6, 7. I'm going to show you what framing looks like. So N always goes in 3. One of the places K can go is I can put K in 2, and I can put O in 4. All right. And then another possibility is I could put K in 4 and O in 6. So these are 2 different possibilities for the K and O pair. What's my other possibility? There's only one other possibility. What is it? Only one other possibility for, 5 and 7, K and 5. All right, so I can put N here, I can put K and 5 and O and 7. All right, so if you're going to frame, this is what we're doing. We're seeing that there are only 3, maybe if we want to get crazy, 4 possibilities. 2, 3, maybe 4 possibilities for a piece of the game. It could be one single element that can only go in one of 2 or 3 places, or it could be a chunk like the KO chunk. Very often, if we're going to frame an ordering game like this, we're going to base it on a chunk like the KO chunk. So I'm going to write all 3 possibilities or all 4 possibilities down on my board, or on my scrap paper, I should say. And then I'm just going to look at them one at a time. So let's look at the top frame, the top situation here. And I want to remember anything that must be, I want to, like, definite rules I want to add. So I know that L cannot go in 6th. What else could I add to this top diagram? What else could I put there that's definitely going to go in a certain spot? Notice I have 1, 2, 3, 4 open spaces. Do I know anything that's definitely going to go in one of those spaces? Look over at your rules over here. Look at what we have going on over in the rules and see if there's anything that's going to be really definite. How about M and P or P and M? Notice M and P always have to be next to one another. Well, there's only one spot there and only one spot there. So the only place P and M can go is they would have to be in some order in one and two. Now, I don't have to draw out both possibilities. I can put them in a cloud. If I put M and P with a little comma between them over these two spaces and a circle around them, that tells me that they can switch around. M and P are going to go in those two spaces somewhere in there. I just don't know the exact order. Right? Okay, so who's left? Who's not on my diagram? I have two spaces. Do I know anything about which elements go in those spaces? First of all, we want to think, what are the two elements that are left? Which two elements are not on my top diagram here? Yeah, L has to be in 4. L and R are the only ones that aren't on the diagram yet, and L can't go in 6, so L has to go here and R has to go here. So in this one scenario with K in 5 and O in 7, this is the only way that can play out. If K is in 5, O is in 7, that's the only way that can play out. M and P in the first two, N, L, K, R, O. All right, so what about the second one? Again, same thing. I have a single space here and a single space here. I don't have room for P and M to go together unless I put them right in the beginning. So I'm going to put M and P in the beginning with a little circle around them to show that they can remind me that they can switch back and forth. And then who's left? L and R again. And L can go in either one of these, and R can go in either one of these. So what I could do is I could put L/R in space 5, and then R/L in space 7. And that just reminds me that either one of those, if there are only two elements that can go in a certain spot, that's the way I can notate that. One spot, spot 5, only two elements that can go there, L or R in this middle scenario. So I write it that way. So now we get down to the bottom. And again, let's think about, we've already placed K in 2 and O in 4. So let's think about our other chunk. You know, notice chunks are really important in these ordering games. So I have this PM or MP situation, and I know that PM or MP, they're going to have to go in one of these, 5 and 6 or 6 and 7. So I could draw a couple more diagrams, but if I really wanted to be a little bit lazy, what I could do is put M and P as a chunk. And I can do a little back and forth arrow here to remind myself that they can switch. And then a little arrow here to remind me that this chunk can go over into spot 7. Now, this isn't the way you have to do this, right? If that looks kind of confusing to you and you're saying, no, I would rather draw, another diagram and show, it's okay to draw maybe one more diagram if you want to show, that M and P could be in 5 and 6 or 6 and 7. But you do want to show that they can be in 5 and 6 or 6 and 7, and you want to remember that they can switch. And then, I don't know if L or R is going to go first. I suppose I could put L/R here in first, or I could just put L and R over off to the side to remind myself that those are the two elements that are not placed in this diagram yet. So what we've just done is framed this game. We've recognized that there is a three-way split. There are only three possibilities, three possible places for the K space O. We have drawn 3 diagrams to show each of those 3 possibilities. And you notice the first thing I did was draw those 3 diagrams and put where K and O will be in each diagram. And then I went back and looked at one diagram at a time and looked for additional inferences. The additional inferences tended to depend heavily on the other chunk and where that M and P chunk is going to go. But by noticing that, where the M and P chunk is limited to being, then I just look at what's left over, and there are just a limited number of places for the L and the R to go. So I've created 3 frames. And the important thing about these 3 frames is these 3 frames represent every possible solution to the game. They represent every world in this game. Every possible solution to this game will be in one of these 3 frames that we just created. There is no solution to this game that doesn't fall into one of these 3 diagrams. So we didn't just start creating hypotheticals willy-nilly, right? We were very, very, definite about this, and we focused a lot on what must be, right? All these exclusions we made are must-be's. The frames that we created are based on a must-be, right? K and O, that chunk, must be in one of these 3 positions. So, there are our initial diagramming that we do here the diagramming the game, making inferences, creating frames. It's based on what must be in the game, what must happen in the game. We're not going down like a could be, maybe this, maybe that rabbit hole. Now, I say that there are some could be's in these frames, like, M could be first or P could be first, but we're keeping very careful track, and it's a limited number of possibilities, a limited number of could be's. A solution could be on any one of these three diagrams, but we're really focusing more on the must be's to get to this point. And again, if you have any questions about this, go ahead and put them in the chat window. One thing I'm going to say about framing right now is that not every game is frameable. So what I mean by that is there are lots of logic games. In fact, more than half of all logic games, I would say 3/4 or more of all logic games are ones that we really wouldn't bother framing. So really, like, close to, if not at or over 3/4 of all logic games, we wouldn't even think about framing. It's only about 1/4 of all logic games. It's only about half of all logic games where it's even possible to do this. It's even possible to frame. And then only about half of those where it's useful, where it's worth doing. But I wanted to, this is a good point. If we're talking about hypotheticals, it's useful to talk about frames and look at a game like this, because this is one of the situations where we would create hypotheticals, and a correct reason to do it. Grouping is, yeah, Catherine, you think grouping is much harder? Yeah, or mixed games, but there are often opportunities for framing and grouping games too. And if you get the idea of exclusions and how to create frames in ordering games, grouping, depending on what diagram you're using, but if you're using like the closed board or open board diagrams that we use, they actually, framing applies pretty well to those too. And if I mention something that I don't really get to tonight, you can just go to our YouTube channel. I'll put a link to that in the chat window if you want. But go to our YouTube channel and you can find other free prep hours where we've gone over grouping games, and maybe even some that have frames. I can't think of anyone that I've done recently where we framed a grouping game, but we'll see. Maybe we might get a chance to talk a little bit about grouping games tonight, but we'll see. So anyway, how's this going? How's everything looked to everyone so far in terms of what we've done? And with practice, you would be doing everything that we're doing. The basic setup here would maybe take you, I don't know, 2.5, 3 minutes. With a little bit of practice, you would be able to do a setup like this in 2.5 to 3 minutes, maybe even 2 minutes or less, if you really get proficient with this. Framing takes, with a little bit of practice, takes maybe another minute, maybe a little bit more than a minute. So if I'm going to spend time on something in logic games, I want to get a payback. I want a reason to do it. I'm not just going to create these frames because I feel like it, right? I want to get a payback. So let's talk about what the payback is. Let's talk about why we bother doing these frames. Let's look at an actual question. So, and maybe just to back up a little bit, the reason why we bother is because once I've created frames, I don't need this initial diagram anymore, really. If I've framed correctly and my frames are, good, effective frames, if I've done it properly, then I can just use the frames to answer all the questions, and I won't need to look at my initial diagram at all. Maybe, maybe a little, but probably not at all. I probably won't need to look at my initial diagram at all. If I'm using frames correctly, I'm doing them correctly and using them in the correct situation. That's why we bother to do this. So if we look at some questions, and we're just going to answer these questions using these frames. If K graduated 5th, which of the following must be true? So top, middle, or bottom, tell me in the chat window, top, middle, or bottom, which of these three diagrams, top, middle, or bottom, represents K graduating 5th? Yeah, somebody said top. Top is the one that has K in 5th. So we don't look, that's the only diagram we're going to look at. We only need this diagram to answer the question. Which of the following must be true? That's what the question's asking. Okay, well, let me look at my answer choices. So look at the answer choices. Compare the answer choices to the top diagram here and tell me what is the correct answer in the chat window. Which of these answers represents something that must be true? Oh, I'm seeing E's come in. Yeah. P graduated first? No. And that's why you really got to know, you really got to show when two elements like M and P can switch. That's why we put that circle around M and P, because they can switch back and forth, MP or PM. So actually, I know that my first two are wrong. P could be first or second. M could be first or second. L graduated second? No, that's not going to happen. L is fourth. R graduated fourth? No, L is way down here at the end. So that only leaves, I don't even need to look at answer choice E if I've eliminated all the other ones, but let's look at it. R graduated sixth. Yep, that must be true in this situation. So you know, this is why we bother framing, because again, if you have these three, or maybe if you can, a game that can be framed allows you to narrow your diagrams down to 3 or maybe 4 diagrams that represent, hopefully 2. Some games you only need 2 diagrams to represent every possible solution. In this game, we have 3 diagrams that represent every possible solution. So I look at a question, I identify which frame or frames I'm going to use to answer this question or apply to this question, and then I can just compare the answer choice to that frame or to multiple frames if I need to, and do that to answer the question. All right. So let's look at another situation. If P was not one of the first 2 friends to graduate. All right. So which frame am I talking about here? Top, middle, or bottom? If P was not one of the first 2 friends to graduate. Yeah, that's our bottom one, right? We know it's not one of the first 2. So I'm strictly looking at my bottom diagram here. And remember, M and P can switch, and they can be in 5 and 6 or 6 and 7. I got to figure out where L and R are. And could be true. I'm looking for a could be true. What's the correct answer here? Okay, I see some answers for A. Could be true that L graduated first. Does it have to be true? No. R could be first and L could be 7th. But notice L and R are the 2 elements that we didn't, we're the most open in this bottom diagram. We don't really know exactly where they go. There are several places where they can go. And the first spot is one of those open spaces. So actually, if I was, they're kind of nice and they gave me the correct answer as answer choice A here. But honestly, even if they didn't, even if this was one of the last answers, I would be gravitating towards answers that involved L or R, because they're the most free elements, the least restricted elements in that bottom diagram. They can go in, there are 3 possible places that L could go, 3 possible places that R could go. So I'm going to graduate, when it's asking me for something that could be true, I'm going to gravitate towards the could be places, the elements that are involved in the could be places of my diagram. So they could have put this down as answer choice D, and they could have had, K and O as the first 2 answer choices. And I would probably skip right by them because they're must-be's. I mean, they would be correct, but what they're probably going to be asking me about is one of the, in a could be true question, what they're probably asking me about is one of the less restricted elements. All right, let's do one more of these. Let's see, what kind of time do we have? Oh, Jennifer asked a really good question. How do you know when you should frame the problem? How do you know when you should frame a game? How do we know that a game is in one of the 25% that you should frame? I actually said it earlier. Does anybody remember? So this is a question in the somebody put in the Q&A. How do we know when a question is one of the ones? Can somebody answer this in the chat window? How do we know when a game is one that we should frame? There were 2 criteria that I put up here. 2 criteria that I wrote down when we first started talking about frames. How do I know that a game is one that we would want to frame? Yeah, we want to be dealing with must be's and cannot be's. And Jennifer, yeah, absolutely. We're looking for something that's a I'm going to pick a color that's easier to read here. So frames are always based on a 2 or 3-way split. That's the first thing that we have to see. Maybe 4-way if we want to get crazy. So there has to be some element or piece of the game that can only go in one of 2 or 3 or maybe 4 possibilities. And we want to be able to make additional inferences. What I mean by that is, notice in each of these frames, in each of these scenarios, we knew something else definite about other elements. It wasn't just like the initial, yeah, K and O can go here, or K and O can go here, or K and O can go here. Like, that's not really giving me any new information. I have to get some additional information about the other elements. So good question, Jennifer. I'm glad you asked us to repeat that, because this is why we frame, because after we do our initial diagram and make inferences, we see a definite 2 or 3-way split. And the split looks like it's going to allow us to make additional inferences. That tells us, yeah, we should try framing. And, you know, to be honest, framing is something you have to practice a little bit. If you're playing a logic game and it looks like there's an opportunity for framing, go ahead and try it. You know, if it looks like there's an opportunity for framing, go ahead and try it and see what happens. Like, there's some things in logic games, I know we all want definite answers, right? We all want the must be trues, not the could be's. But honestly, there are a lot of things that we show you in these free prep hours, or a lot of things that, you know, you'll learn in an LSAT class, or a lot of the things that you'll learn from, you know, using a book or something like that, that you can't just like absorb. You have to, you know, you can't just listen to it once and then go do it. You have to be willing to experiment and practice. And frames are one of the things that you should experiment with and practice with. Now, the other thing I'm going to say about frames, though, is they are useful, but again, realize that not every game is one that can be framed. And the other thing is, you don't have to frame a game. Even if a game is frameable, you don't have to frame a game in order to answer the questions correctly. You can answer questions correctly in this game we're looking at right now without framing at all. Totally fine if you don't frame. So what do I mean by that? Let's go back to this question. If K graduated 5th, which of the following must be true? So I took away your frames. We're just going to dive in and answer questions. Let's say we decided not to frame, or we didn't know about framing, right? We just decided to go ahead and try to answer questions using our original diagram. So yeah, Catherine, you suggested what we should do. What we can do to answer a question like this is just create, we call it framing a question sometimes. We're just going to create a diagram based on this condition that they gave us, right? They said, if K graduated 5th. So just based on that piece of information that they're giving us, I can put K in. I usually put my numbers on my temporary diagrams because I don't want to have to think. So I put K in 5th, and then O has to be in 7th then, right? So what's the next thing that I would want to place on this diagram? What's the next thing going on over here in my original diagram that would be important to think about in a situation where K is 5th and O is 7th? Yeah, M and P, right? I got to think about that other chunk. So where do they go? They're going to go in 1 or 2. So M here, P here. I'm not sure the order. And then, all right, well, who's left? L and R, right? L and R are the ones I haven't placed here. Do I know anything about L and R? I can go back and look at my original diagram here and say, oh yeah, L can't be 6th. So that means R has to be here and L has to be here. So this is called framing a question. It's a different way of approaching it. Rather than creating the frames up front, you can just, when you get to one of these, we call these conditional questions. They're giving you a new condition. When you get to a question like this, it doesn't mean that K is 5th for the whole rest of the game. It just means to answer this one question, you're considering a situation where K is 5th. So you just draw out that situation and create that situation. And then once we've done this, we can look at the answer choices. And again, we come up with the same answer, right? If K is 5th, which of the following must be true? And again, it's still E, R graduated 6th. So we get to the same place without doing the frames up front. And the reason I'm showing you this is because I want you to experiment with frames, but I don't want you to be worried about frames, right? I don't want you to be like nervous, like, oh, frames seem a little confusing. I don't really get frames. Like, What's more important is diagramming effectively and learning to make inferences based on the must-be's or the cannot-be's, the definites. If you get good at this part of it, then you can still do really well in logic games. Frames are kind of the icing on the cake. Maybe if you're already getting like consistently 21 or 20 out of 23 questions correct in a logic game section like all the time, and you're trying to squeeze those last couple points, maybe that would be a case where you'd want to get really good for framing because it can speed you up a little bit. But you know, we can just do it on the fly as we need to. So I know we're getting close to the end of the hour here, and if you have to take off, I will say thank you very much for being here. But I want to show a couple. I'm going to show you one more thing, and then I'm going to answer a couple of the questions that I see in the Q&A. So if you can stick around for another minute or two. Let's look at one other thing, another way that we use hypotheticals. So we've just looked at a few different ways of using hypotheticals. Hypotheticals are what we use when we create frames. That's how we created frames. We recognized that there are 3 possible positions for this K and O chunk. We drew out those 3 diagrams showing those 3 positions, and each of those diagrams is a hypothetical, right? If we go back to the framing, let me just show you that. Each one of those diagrams is in itself, each frame is a hypothetical. And we're, you know, the process we followed a little while ago to create these frames is the process that you can follow again and again and again to create hypotheticals, to test a situation. I want to know what happens if K is 5th and O is 7th. I want to know what happens if K is 4th and O is 6th, if K is 2nd and O is 4th. I create those 3 scenarios, and then based on my original diagram, I fill in the additional information. So that's one way that we, you know, when we create hypotheticals, it's one reason we do it, is to create frames. The other reason that we create hypotheticals, or the other reason we might want to do it, is in a scenario like I showed you just a moment ago. We can create hypotheticals on the fly to answer an individual question. When we're faced with a conditional question like this, even if we don't have any frames, we can create a hypothetical on the spot to test that situation. Another time when we might want to use hypotheticals is just to test. So you'll see questions like this, right? Which of the following could be true? So maybe I haven't created frames. If I had frames, then, you know, it would make it easier to answer a question like this. But if I was faced with one of these questions, this is called an unconditional question. They're not saying like if M is first or something like that. There's no if. They're not giving us an if. They're just asking which of the following could be true always, always, always in any solution to the game. So another way that I could use hypotheticals is just to test an answer choice. If I see an answer choice, you know, or maybe I just test the first answer choice to see if it's correct. Which of the following could be true? So let me see if I can create a solution that follows all the rules where K is 4th. 1, 2, 3, 4, 5, 6, 7. Yeah. I put the right number of elements in here. So if K is 4th, okay, well, O has to be 6th. So what else? M and P have to go over here because I need 2 spaces for M and P to go. And then I can put L here and R here, or those could switch. So what I've just done is shown that we can create a solution that follows all the rules where K is 4th. And, you know, how long did that take me? I'm sitting here blabbing about it. But how long did it take me? 10 seconds? You know, 15 maybe? So if you practice a little bit and you get to the point where you can create a hypothetical like this in like 15 seconds, let's say 15 seconds. Okay, so, and maybe answer choice A isn't the correct answer, right? Maybe they stick this one all the way down in answer choice E. So I have answer choice A, B, C, D, E, and I have to create hypotheticals to test all these answer choices. So 15 seconds, I'm done with A, I eliminate A. 30 seconds, I'm done with B, and then I'm at 45 seconds, I've eliminated C, and then 60 seconds, I've eliminated D, and I don't have to test E. If I've created hypotheticals to test answer choice A, B, C, and D, and none of these are things that could be true, then I know E is the correct answer, even if it's the very last one. So in a minute, if it takes you a minute to answer a logic games question, that's a pretty reasonable amount of time. There's nothing wrong with taking a minute or a minute and 20 seconds to answer a logic games question. It's nice if you can answer some questions faster than that, but you can get a pretty decent score that way. So this is a pretty labor-intensive process. Creating hypotheticals to test every answer choice is a labor-intensive process, but if you're good enough at it, you could answer almost any question by doing that in about a minute to a minute and 20 once you have your initial diagram and inferences without any frames. So this is another way that we use hypotheticals. What we've just done this evening in our time together is I've tried to give you like a whirlwind tour of all the ways that we might use hypotheticals in a logic game. And so here they are, just as kind of a summary. A hypothetical is one possible valid solution to the game. So we use hypotheticals when answering conditional questions. We don't need to have frames to answer any question in LG. We can use a hypothetical like I showed you a couple minutes ago, just on the fly. If you get a question that gives you an if, a new condition in the beginning, create a diagram that shows that new condition and then use that to answer the questions. We can test individual answer choices. If I really have to sit there and just throw out a possibility to test an answer choice, I can do that if I know how to create hypotheticals. And then when framing, again, it's not a huge number. It's not the majority of games that we can frame or would want to. But if you're looking for those opportunities, every time you create frames, you're practicing this process of creating hypotheticals. And these are the main times when we use them. So it's really worth thinking, like, well, I have that starting point. What's my starting point for this little diagram I'm going to draw, this little possibility I'm going to draw out? And then look at the other rules or the other pieces of the game and notice like the must-be's. Oh, M and P, if K and O are here, M and P have to go in this other place. And then think about the elements that aren't on the diagram yet, which ones are left. That process that we followed earlier for creating those diagrams. This is something that you'll use over and over and over again in the logic game section, and it's something that's worth getting good at. So I promised that I would, for folks who have to take off, I promised that I would put a few links in the chat window. So if you are joining us from home and watching this on YouTube, you don't have a chat window. I guess you do. You have the comment section, but that's not what we're talking about. This is for the people who are here joining us live tonight. I'm going to put a couple links in the chat window. If you're watching this on YouTube, then you can find these same links at the in the information for the video. I promised that I would also include a link to our YouTube channel. So if you're watching this on YouTube, then you're already there. But if you are here joining us tonight, I'll also put the link for our YouTube channel in the chat window. And that way, if you want to go check that out, you have the opportunity to do that. So yeah, thank you all very much for being here. There are a couple questions in the Q&A that I'm going to go ahead and answer before we call it quits. So let me look at these. Let me just put up a little bit of information here. And let me go ahead and answer these questions in the Q&A. So how do you know when you should frame the problem? How do you know when you should frame a game? Yeah, we talked about that. Jennifer, you answered the question. We want to make sure there's a clear 2- or 3-way split. If you don't see a really clear split like that, then you don't even bother framing. And then, when you draw those 2 or 3 diagrams, you should be able to add things to those diagrams. There should be additional must-be's that are triggered. And sometimes you just got to practice with that a little bit before you get a handle on it. During the LSAT, would they have sub-questions from the main question, like if K graduated 5th? I'm not sure, the anonymous attendee, I'm not sure what you mean by sub-questions from the main question, but I think maybe what you're talking about is something we actually looked at. Something like we actually looked at, where for every game that you play, right, every time this is the way logic games works. You're going to start with the scenario and the constraints, right? They're going to give you this. You're going to, and I'm sorry, let me know if I'm not answering your question. Not giving you the answer you're looking for, but they're going to give you the scenario and the constraints, and then you're creating this diagram just to be able to help you answer the questions. That's all the diagram is for. You don't get any points for creating the diagram, right? The diagram is just a tool that we're going to use to answer questions. So we create the diagram, and then we think about our must-be's, right? Our definites, and we like these exclusions that we made. And then we do the big pause, and we think about, you know, the most restricted thing in the game, and we think about any elements that don't have rules. And then if we are going to frame, we do it at this point. And then you're going to be asked questions about that original scenario and the constraints. I mean, ideally, you could answer questions without doing a diagram. It's harder that way. It's not the recommended way, but yeah, then they're going to ask you a bunch of questions like this. And the idea is when you're asked a question, you're using your original diagram or the frames, if you've framed, to answer that question. And so if there's some other type of sub-question that you were thinking of, or if that didn't answer your question, then you can let me know. But I think what we'll do at this point is we'll stop the recording. We'll say thank you to the folks watching at home. Hope you enjoyed tonight. Hope this was useful. Again, it'll be up on YouTube. Watch it a couple times if some of it went by a little fast, especially if you're really new to this. Look at our other YouTube videos also, because we have quite a few of them up there now. Some of them go over like the diagramming process and making inferences in a little bit more a little bit slower detail, a little more careful detail. So if that part of it went by a little fast, or you're still a little unsure about diagramming, maybe you can watch some of those. We have other free prep hours where we look at other types of games like grouping games. So you might want to look at those if you're interested in that. But check out our other recordings. Come to one of our free classes. I mean, it doesn't cost anything. It's 3 hours of LSAT instruction for free. Session 1 of our actual LSAT complete course you can attend for free. So come on and check one of those out. And hopefully we'll see you back here again for another free prep hour sometime.